Hey guys, welcome back to another week of school. This week we have two lessons. We're actually finishing up the unit that we're working on, and this has just been sort of random topics that are kind of important to review or useful to review for pre-calculus. So we're going to finish up these two topics, and then the fact that we're at the end means that we are having a test soon. So the end of this week will not be our normal 10-question quiz where you get as many tries as you want. It will be the actual test. So what that means is before we have the test, we will be having a practice test, and that's going to be very important for you to do along with the actual lessons. So 2 lessons this week, that's fewer than normal, but then spend time reviewing and then have the actual test. Now in calculus, there's a lot of geometry. It's not the typical geometry that you might think of, like triangles and squares and shapes and things and volume and that sort of thing. It's analytic geometry, which basically it's geometry on the xy axis. So what we're going to be doing deals a lot with the xy axis, the coordinate plane, the Cartesian plane, whatever you want to call it. So today we're going to focus on 2 topics, distance and midpoint. So we will be dealing with line segments on the coordinate plane or the xy axis Cartesian plane, like I said. For one thing, we will be finding the distance between 2 points, also known as segment length. We'll be finding the midpoint between 2 points, and we will also find, wow, that's sloppy. We will find an endpoint of a segment if you are given one endpoint and a midpoint. So hopefully if that doesn't make any sense to you once we start getting into it, it will. Mostly what we're doing here is formula manipulation, and this will come up from time to time. There are concepts, there's things you need to learn on a conceptual level, but when it comes down to it, what are you actually going to be doing? You're going to be manipulating formulas. So this is a formula you should have seen before whenever you took geometry, probably 2 years ago for most people. So to find the distance between 2 endpoints of a segment, you subtract the x values, square it, subtract the y values, square it, add those together, and then square root it when you're done. So you'll see several examples of that in just a minute, but I am going to explain where this comes from because it is kind of important. So what I've drawn here is some generic made-up line segment with 2 endpoints. D is representing the distance, which you see in red, between those 2 points. The theory behind how this works is imagine creating a right triangle out of these points. You know that on the xy axis, all the grid points, pretend that's a right angle, all go at right angles. So to find the bottom side, you can subtract the x's. To find the vertical side, you can subtract the y values. So subtract the x values, that gives you this length. Subtract the y values, it gives you this length. And then you know that you have this thing called the Pythagorean theorem. Well, let me write it this way. C squared equals a squared plus b squared. Or c equals the square root of a squared plus b squared. Wow, that's super sloppy. All right, give me a second. That's a little better. So if you say, okay, this is A and this is B, and instead of C, we're using the letter D for distance, you can substitute this and say, okay, the distance is going to equal A, which is, oh, I just found where I made a mistake. That should be 1 because you subtract those. So x2 minus x1 squared, there's the squared, plus, there's the plus sign, y2 minus y1 squared. There's that square. So this formula is really the Pythagorean theorem, which I'm sure you're familiar with. You can't make it this far into mathematics in school without knowing the Pythagorean theorem right there. So that's it. The distance formula is just a really screwed up looking version of the Pythagorean theorem. Now, midpoint. No, I don't really have a diagram here. Here, let me go up to the previous diagram. If you want to find, let's go back to line segment D right here. The midpoint is the point right dead center. So that has coordinates. Let's call it xm, ym. So the subscript m stands for midpoint. xm, ym. You can find that midpoint by adding the x's, dividing by 2, adding the y's, divide by 2. And this is a concept you should totally be familiar with. It's an average. When you add two things together and divide by 2, you're finding the average, the halfway point in between. If you took two tests, you got a 90% on one and 100% on the other, add 100 plus 90, it's 190, divide by 2, 95. Your average is 95, and if you think about it, 95 is halfway between 90 and 100. So to find the physical halfway point between two other points, you just take the average of the x's and the average of the y's. Now, in a lot of situations, a lot of classes, excuse me, you are asked to memorize formulas. Just the nature of what we're doing right now, you're at home working on your own. You can certainly have these written down on a formula sheet when we get to that one, this one up here, for reference. When we take the test, it's totally okay to have a formula sheet. One of the typical issues is people confusing the two formulas. So the distance formula, you subtract the x's and the y's, whereas in the midpoint formula, you add them. And that's an easy thing to confuse, especially if you've got test anxiety and you're frustrated. You can just get it wrong and then bomb questions like this on a test. So feel free to memorize if you want to. Maybe you already do from geometry, but also feel free to have a study sheet or a note sheet or formula sheet, whatever you want to call it, at your disposal. All right, lastly is the endpoint formula. So for the endpoint formula, you're actually told what the, hold on a second here, you're told what one endpoint is, you're told what the midpoint is, and you have to calculate the other endpoint. So x2, y2, that stands for like the other endpoint, and you find that by doubling the midpoint and subtracting the other endpoint. Double means multiply by 2. Double the midpoint, subtract the endpoint. It's really this formula inverted. So add and then divide by 2, multiply by 2, then subtract. Everything's sort of flipped around, reversed. All right, let me get into it so we're not all day on this. I'm just going to walk through several examples, show you how to execute these formulas for each problem. As normal, I'm going to do the evens. Your homework will be the odds. You need to check yourself. And don't forget to write a grade. You can write a grade, right up here when you submit it, or you can type a grade into the comment section. But do write a grade on every assignment. Okay, so looks like what we're doing here is kind of the reverse of what I taught it. So we're going to start with midpoints. Find the midpoint given the endpoints. So the midpoint, of course, is a point. The formula says we need to add the x's, divide by 2, add the y's, divide by 2. So that's our formula. X plus x divided by 2, y plus y divided by 2. So what does this work out to equal? Negative 18 divided by 2, comma, 3 plus negative 8 is negative 5 divided by 2. And that is negative 9, comma, negative, 2.5? 5 divided by 2, 2.5. Let me check the answer, see if they do it in decimal or fraction. They do it in fraction right there. So there it is. Let's look at number 4. Find the midpoint. So we're going to add the x's, divide by 2, add the y's, divide by 2. 3 plus negative 5 is negative 2 over 2. 9 plus 4 is 13 over 2. Negative 2 over 2 is negative 1. 13 divided by 2. 2 goes in 13 6 times with 1 left over, so that's 6.5. Negative 1, comma, 6.5. And there it is. So these are pretty simple. I mean, you take any kid in geometry, anyone with basic ability, calculator if need be, teach them this, and it should be not a big problem. This next one, this next set of problems is a little more complicated. So we're told that 4, 3 is one endpoint. So 4, 3 is one endpoint. Negative 6, 5 is the midpoint, call M. Question, what is the other endpoint? So, you can get creative and try to work this through and come up with a solution. And, if we were in the classroom, we could spend a day where you get to experiment and come up with a method. Being an online class like this, I've just chosen to give you the formula and let you do it. So if you go back up here and look, where is it? Right here. Double the x, double the midpoint, subtract the x, double the midpoint, subtract the y. So I need to do 2 times -6, subtract 4. So this is xm, ym, because midpoint starts with m, x1, y1, comma, double 5, subtract 3. And you know what? Parentheses inside parentheses, not always the best looking thing. I might use the dot for times here. Okay, so what is this? 2 times -6 is -12, take away 4, comma, 2 times 5 is 10, take away 3. -12 take away 4 is -16, 10 take away 3 is 7. So the other endpoint should be -16, comma 7. And there it is. If I'm going too fast, obviously pause, go back, re-watch it, whatever you need to do. Here, I'll re-explain, or when I do number 8, I think I went too fast on that one. I'm going to slow down. So the endpoint, you can call it x1, y1. The midpoint, xm, ym. So the formula is 2xm minus x1, 2ym minus y1. So that's 2 times 0 minus -10, 2 times 5 minus 6. So I put this, let me go back. I put this 0 here, this -10 here, and then I put this 5 here, this 6 there. Now if I just work out the math, 2 times 0 is 0, minus -10 is actually +10, 2 times 5 is 10, minus 6, that gives me 10, comma 4. Let me scroll down to number 8, and there it is, 10, 4. 10, 4, that's what the truckers used to say on the CB. 10, 4, good buddy. Okay, that's really lame. I'm old. Get over it. All right, so finding the midpoint is simply adding, dividing by 2. Finding an endpoint, you multiply by 2 and then subtract. Find the distance between points. So I'm going to rewrite the distance formula right here. Square root of x2 minus x1 squared plus y2 minus y1 squared. I remember when I was in high school, I'd confuse, was this a plus and this minus, or were these pluses and that was supposed to be a minus? That was always a challenge for me. Actually, I'm going to move this up here. Okay, so just call this x1, y1, x2, y2, and it's more or less plug and chug. So 7 minus -1 squared plus -2 minus -8 squared. Boy, my handwriting is really bad in general. It's worse today. I think maybe I had too much coffee, so please forgive me. I'm a little jittery with the handwriting. Okay, so this works out to be 7 minus -1. Minus is plus, so that's 8 squared. -2 minus -8 is plus, so that would be 6 squared. So that is the square root of 64 plus 36. So d equals the square root of 100. And hopefully you know the square root of 100 is 10. So the answer to number 10 should be 10. There it is. Now you can see how I showed all the steps. Honestly, I show steps like this because I'm a teacher and I should make it as plain and illustrative as possible. If you consolidate this and you write down 1 step or 2 steps, I totally understand. So I don't want you to feel like you have to fabricate fake steps just to make Mr. Haskell happy that you're showing your work and I can see your work, stuff like that. So do it the way you would normally do it. Just write something down that makes sense so it's obvious you're not just copying answers. Okay, number 12 is our last one. So find the distance between these 2 points. x1, y1, x2, y2. Distance equals the square root of -7 minus -4 squared plus -1 minus 1 squared. And really, I'm just following order of operations here. So -7 minus -4, that's plus, that's -3 squared. Notice, because this is a negative, I left it in parentheses. Up here, I didn't bother with any parentheses because those were positive numbers, but it's kind of important there. Okay, bring down the plus sign. -1 minus 1 is -2, again parentheses. So the square root of -3 is 9, and the square root of -2 is 4, not square root. -2 squared is 4, -3 squared is 9. Okay, let's say it correctly. 9 plus 4 is 13. Now, is 13 a square number? No. You could grab a calculator and it'd spit out a decimal answer for you, but we don't really want decimals right now. We have simplified radicals in the past, or Algebra 2, if we haven't done it in this class yet. But 13 is a prime number. It only breaks down into 1 and 13. So you cannot simplify this either. So square root of 13, or sometimes we say radical 13, should be the final answer for number 12. And there it is. Okay, so the long story is we're getting into analytic geometry, and you have to master these concepts. The short story is there's 3 formulas. You need to learn how to work them out. And that's what it all generally boils down to. So once again, we are on the last week of this unit of instruction, so that means we'll be having a test. So you need to get the work done, this paper, the next one coming up, watch the lessons, get it done. Do the review as soon as it's available. Review over and over if you need to, and then we'll be having a test at the end of this week. As always, contact me if you have questions. Good luck. Have a great rest of the day.